Hello everyone, let's look at Leetcode question 938, range sum of binary search tree. At time of recording, this question has 6.8 thousand upvotes and 369 downvotes. The question is, given the root node of a binary search tree and two integers, low and high, return the sum of the values of all nodes within the range of inclusive low to high. Okay, we'll go into depth to these examples, but really quick we can see that the low is 7 and high is 15 for this first example. So the nodes 10, 7, and 15 will be added up, and that is 32. In the second example, we have low of 6 and high of 10. We start at node 10. So 10, 7, 6 are the three nodes that are added together, and that's a total of 23, so we return 23. The constraints are that the number of nodes in the tree is in the range between 1 and 20,000, and the node values themselves will be between 1 and 100,000. So low and high will be between 1 and 100,000 as well, and all the node values are unique. Okay, running through the code really quick. So we first define the self.totalSum to be 0, and we do the self.totalSum because we need multiple instances of this variable, so we instantiate it as self.totalSum. And then we have the depth first search node, which checks the node values and checks if it's within the range. If it is so, then we add it to the total sum and then make a new instance of the node values to the left and to the right to do the same thing. However, if the node value is less than low, then we can't add it to the total sum, so we simply make a new instance to the node to the right, because nodes on the right will be greater than the current node. Otherwise, if the node value is already greater than the high, we have to do the opposite, so we do an instance of node.left, so it'll be a smaller node, and we check then if it's within the range for us to add to the total sum. Okay, and we then do the call, we do the depth first search call, the root value, and we return, finally, the total sum. Okay, so let's look at the first example. We start with node 10, so depth first search root is 10. And so we go to the method call and we check if not node return, so it is 10, it's a node, if low less than or equal to node value less than or equal to high. So is 10 between 7 and 15? It is, so self.totalSum, we add the node value, so total sum is 10 so far. Then we do the instance call of the node.left and node.right values. So the next calls are 5 and 15. So we're creating new instances for these two different calls. And so we start once more. Let's start with 5 first, and we check if not node return. Okay, that's not true. If low high is between this value, so 7 and 15, nope, so we can't add it to the total sum because 5 is less than 7. So we check else if node value is less than low. This is true, 5 is less than 7. Then we create another instance for the depth first search to the right. So 5 never made it to the total sum, but now we have a 7 here. Okay, before we go to the 7, let's check what's happening on the right side of this call. So node.right, if you remember, was called, and we created the instance, so we check if not node return. That's not the case. If low less than or equal to node value less than or equal to high, this is true because the range is inclusive for 7 and 15, and the node value is 15. So we add 15, self.totalSum plus equals 15. So far 10 plus 15 equals 25. Then we do the same thing, depth first search to the left and to the right. So to the left is nothing, and to the right is 18. However, you can check already that 18 will be greater than the node value of this range, so we won't add it to 25, and we can simply return eventually nothing, because it'll end up here where the depth first search value is greater than the high, so we simply check its left and right values, and there's nothing to the left and nothing to the right. Okay, so that's the end of the right half of the subtree. Let's check what's happening on the left again. So the 7, if you remember, was called, and we created then a new instance of the node, and it is actually between 7 and 15, so we can add it. So 25 plus 7 is 32. And we do the same thing, node.left and node.right, new instances. There's nothing to the left and nothing to the right of node 7, so we simply return these values because they're not nodes. okay? And finally, we return right back up to where we started, to the initial recursive call, which was the total sum of the initial 10 after we called these depth first search values. And then so we can simply exit the function with our total sum updated to 32, and we return this value. Okay, let's look at this next example. And we start at root node 10 again, but the range is now low of 6 and high of 10. 6, 10. So we start at 10, and then we do the depth first search of root value. If not node, return. Okay, definitely a node. If between low and high, yes, 10 is actually between 6 and 10 inclusive, so we do self.totalSum plus node value. Total sum becomes 10. Then we do the depth first search instances of the left and right node, so we do another call to the 5 node and 15 node. So starting with the left side, we'll check this one out first, and it's called up here to the depth first search, and we check. If not node, return, no. If between the range of 6 and 10 inclusive, that's actually not true, so we don't add to the total sum, and we do this else if statement. If node value is less than low, yes, 5 is less than 6, okay, so we go to the right to check for node values that are greater than 5, which are more likely to be in the range of between 6 and 10. So we do a call to 7. However, on the right hand side you have the same thing happening, but for the greater value. So for 15 it's called here again, and we check, okay, if not node, return. Okay, it's definitely a node. If between low and high inclusive, 6, 10, nope, 15 is too big. So we then do this else if statement. If node value is greater than high, 15 is greater than 10. Yes, that's true. So we have to check for smaller node values, and perhaps then it will be in the range. But for now, the 15 is not in the range, so we go to the left for smaller nodes. Okay? And we can get rid of this 13 because we know it's not going to be in the range, but if we loop through it again, we'll see that it's not between low and high, and then in that case, it's going to ask us to check the nodes to the left of it, left of the range high. So there's clearly nothing to the left. It's going to return not node, so we end the depth first search calls here. However, on the right hand side we have the 7, and it is called, it's a node, and it's between the low and high because it's between 6 and 10. So in that case we add 7 to 10, so 10 plus 7 is 17. 17 is our current sum right now, and then we do depth first search left, 6, and depth first search right. That's nothing. So we then do the left, because its value actually, it's 6, it's going to return something. So we say, okay, it's between low and high, 6 and 10. It is. 6 is the inclusive low, so we add 6 to total sum here. So 17 plus 6 is 23. 23 is so far the total sum. However, it's going to ask us for node left, node right, but as you know, this is going to return nothing. So we can simply exit then the depth first search, because we can backtrack all the way up to the initial call of 10, and we could see that it's just an if statement, there's no loops, so we simply exit the method and return total sum, 23. Okay, so let's check the solution. Fantastic, it works. And the time complexity is O of n. Since it's a depth first search traversal, we visit every single node once in the binary search tree. The space complexity is O of h, where h is the height of the binary search tree. This is because the solution uses recursive calls to traverse the tree, and the max depth of the recursive calls is equal to the height of the tree. This is worst case, so it's O of h. Alright, that's the end of this problem. Thank you for watching.